Hello and welcome to another episode of Continuous Improvement, the podcast where we delve into the latest trends, challenges, and breakthroughs in technology, aiming to help you stay ahead in the rapidly evolving landscape. I'm your host, Victor Liang, and today, we're going to explore a fascinating topic in the field of machine learning, Chinchilla scaling laws. In the dynamic world of machine learning, one persistent challenge is striking the right balance between model complexity and dataset size to achieve optimal performance. Recently, a breakthrough in understanding this balance has emerged, providing valuable insights into the interplay between model parameters and the size of the training data. These insights come from what we call the Chinchilla scaling laws. Today, we'll dive into these laws, their implications, and how they can be applied to enhance the efficiency of machine learning models. Let's start with a basic understanding of what Chinchilla scaling laws are. These laws are based on the premise that there is a specific ratio between the number of model parameters and the amount of training data that maximizes performance. This concept is particularly crucial for large-scale models where the cost of training and computational resources can be prohibitively high. Essentially, the Chinchilla scaling laws suggest that for a given amount of computational budget, there is an optimal balance that needs to be struck to avoid underfitting or overfitting. One of the key takeaways from Chinchilla scaling laws is that as models grow larger, the amount of training data required to fully utilize the model's capacity increases as well. Conversely, if the training data is limited, it is more efficient to train smaller models to avoid wasting computational resources on parameters that cannot be effectively learned from the data available. Now, let's talk about the implications of these laws. There are several key benefits to adhering to Chinchilla scaling laws. 1. Efficient use of computational resources. By following these laws, researchers and practitioners can allocate computational resources more effectively. Instead of blindly increasing model size, they can optimize the ratio of parameters to training data, leading to better performance with less waste. 2. Improved generalization. Models that are too large for the available data tend to overfit, capturing noise rather than the underlying patterns. Following the Chinchilla scaling laws helps in designing models that generalize better to unseen data, improving their real-world applicability. 3. Cost reduction. Training large models is expensive, both in terms of time and computational power. By optimizing model and dataset size, organizations can reduce the costs associated with training, making advanced machine learning more accessible. 4. Guidance for future research. These scaling laws provide a framework for future research in machine learning. Researchers can experiment within the bounds of these laws to discover new architectures and training methodologies that push the limits of what is currently possible. Applying Chinchilla scaling laws in practice. So, how can we apply Chinchilla scaling laws effectively in practice? Here are some steps to consider. 1. Assess your data. Evaluate the size and quality of your training data. High-quality, diverse datasets are crucial for training robust models. If your dataset is limited, focus on acquiring more data before increasing model complexity. 2. Optimize model size. Based on the size of your dataset, determine the optimal number of parameters for your model. There are tools and frameworks available to help estimate this, taking into account the specific requirements of your task. 3. Iterative training and evaluation. Use an iterative approach to train your model. Start with a smaller model and gradually increase its size while monitoring performance. This helps in identifying the point of diminishing returns where increasing model size no longer leads to significant performance gains. 4. Leverage transfer learning. For tasks with limited data, consider using transfer learning. Pre-trained models on large datasets can be fine-tuned on your specific task, effectively utilizing the Chinchilla scaling principles by starting with a well-trained model and adapting it with your data. 5. Monitor and adjust. Continuously monitor the performance of your model on validation and test sets. Be ready to adjust the model size or acquire more data as needed to ensure optimal performance. In conclusion, Chinchilla scaling laws provide a valuable guideline for balancing model size and dataset requirements, ensuring efficient and effective machine learning. By understanding and applying these principles, practitioners can build models that not only perform better but also make more efficient use of computational resources, ultimately advancing the field of artificial intelligence. Thank you for tuning into this episode of Continuous Improvement. I hope you found this discussion on Chinchilla scaling laws insightful. If you enjoyed this episode, please subscribe and leave a review. Stay curious, keep learning, and let's continuously improve together. Until next time, this is Victor Liang, signing off. Remember, the journey of improvement is ongoing, and every insight brings us one step closer to excellence. See you in the next episode.